My name is Pietro Bilancia. I'm a postdoctoral researcher at the University of Genova, and I'm here on behalf of Professor Berselli, who is the chair of the session. I also have a co-chair who is here with us, so Vittorio Solina.
Thank you.
And first of all, I'd like to introduce you to this session entitled Eco-Design and Sustainability-Oriented Processes for Factory 4.0. This session comprises 5 talks, and I would like to remind each speaker that they will have 13 to 15 minutes for their presentation. And then we will have a short discussion after each presentation, so with some question and answers. So our first paper is entitled Waste Reduction in Printing Process by Implementing a Video Inspection System as a Human-Machine Interface. And the presenter is Carlo Alberto Perez Juarez.
Yeah.
Are you here with us?
Yeah, I'm here.
Great. When you want, you can proceed. Go ahead and share the screen and start the presentation.
Okay.
I remember you once again that you have more or less 15 minutes for your presentation.
My presentation during 10 minutes at least.
Great.
So I think I'm okay.
Yeah, I think so.
Let me share my screen. You can see it?
Yeah.
Okay. Good afternoon, everyone. My name is Carlos Perez. I'm an electronic engineer from National University of Mexico, and I'm going, oh, sorry, this is not the first one. Let me start again. Good afternoon, everyone. My name is Carlos Perez. I'm an electronic engineer from National University of Mexico, and I'm going to present you the paper with the topic Waste Reduction in Printing Process by Implementing a Video Inspection System as a Human-Machine Interface.
I think you are sharing the wrong one, because the one we are looking at is named Video Inspection System Price and Selection.
Yeah, let me start it again, because I think
there are many options for sharing the screen, and you should select the last one on the left, so that to share your actual screen and not just a page.
Okay. You can see it now?
Yeah, we see the presentation is the same as before. Video inspection system, price and selection.
I don't know what happened. I select the last, but only let me close the presentation. And open it again. I don't know what happened. You can see it now?
Yeah.
And looks well in the first slide?
Yes. Yes.
Okay, so let's start. Good afternoon, everyone. My name is Carlos Perez. I'm an electronic engineer from National University of Mexico, and I'm going to present you the paper with the topic Waste Reduction in Printing Process by Implementing a Video Inspection System as a Human-Machine Interface. First of all, I want to talk about the problematic that exists in the graphic industry because the most recent advances in advertising and marketing have reaped a need for higher quality printing jobs in regards to design and finish. Here it's important to say that in consequence, there is a decrease in the volume of the printing jobs in terms of linear meters per job, but also an increase in the diversity of jobs. Let me explain this with an example. Think in milk products. Years ago, we only had the regular milk and we can choose between 2 options, the half-liter presentation and 1-liter presentation. But nowadays, we can choose between many variety of options, like the regular milk, the lactose-free, the fat-free, with protein for 40 years and more, and also between many different flavors. Add to this, also we can choose with a lot of options of size. All this has led to an increase in waste due to production errors and consumer rejects. And as a solution to reduce this waste,
Carlos, I'm sorry to interrupt you again, but we still see your first slide. I don't know if Vittorio can confirm that, but I still see the waste reduction, the title, the first.
Yes, I confirm. We can.
And I think you may want to take some minutes to figure out your problem, and we can go ahead with the second presentation, and then we will call you back after the first presenter, which is
okay. I don't know what is the problem, but because I'm sharing the PowerPoint, and I don't know what's going on.
You should share your screen instead of the PowerPoint page, so that it will update instantaneously when you switch from one slide to the next one. But okay. Let's try now or later, as you prefer, but in case you want to take some more time to figure out, we have to go ahead.
Can we do... I will share later, because I don't know what happened.
Okay.
Here. Okay. Because the app didn't permit me to share the full screen. Don't give me the option. Okay,
I'll let you figure out. Okay, let's go ahead and see if we have the second speaker. The paper is entitled Reaching Sustainability Through a Smart Water Crisis-Proof Industry.
Yes, we are here.
Perfect. If you want to share the screen, we are here.
Sure. Thank you. Okay. I'm going to share it, please. Okay. Just a second, please. And okay, I'm trying to. Okay. Okay, I will share. Okay, can everyone see it?
Yes.
Okay, perfect. I'm going to start then the presentation. Okay, hello everyone. We are going to present the paper with the title Reaching Sustainability Through a Smart Water Crisis-Proof Industry. We're the authors from the Technological Institute of Hermosillo and the National Autonomous University of Mexico, from the Department of Operations Research and Industrial Engineering. A dream becomes a goal when action is taken towards its achievement. So in this content, we're going to talk about an artificial cloud and smart water crisis-proof industry concept. And within the context,
well, according to the United Nations estimates, by 2030, global water will experience a 40% deficit. And for 2050, the world's population will rise in 2 billion people. Okay, so as we can see in the pictures, well, we have a lot of deficit of water and a lot of people is having trouble with it. And the fact that 2 billion people drink contaminated water, 785 million don't even have access to drinkable water, and 485,000 die from diarrhea because of bad quality drinking water. All of this is a third of the deaths due to COVID-19 so far. Industry takes 20% of water withdrawals, and this confirms what Edward Barber said. Water global crisis is largely due to inadequate and poor water management, rather than lack of water.
So with this in mind, governments, organizations, and also companies have ideated water schemes for changing hydric practices and infrastructure, the whole governance of water, for spending less to achieve more, by minimizing the impact of human activities on the natural environment, minimizing also negative impacts, with integrated bio-inspired water administration systems, and also water waste to minimal volume. So these schemes have made whole communities and even countries like Singapore change their situations from survival to sustainability. These schemes, like the 4 taps in Singapore, want to administer the resources for hydric self-sufficiency by making the city, the industry, having better management in this area. They also have drought mitigation. In the case of the water-sensitive urban design in Australia, they have bio-inspired techniques for minimizing negative impacts on urbanization. So they build natural systems, urban environments, and they have contaminant remotion. Also, in China, sponge cities like Shenzhen have this treatment model. They have multi-criteria management of water. However, each of them do not have a specialized artificial intelligence algorithms for their schemes, and they have huge cost and also huge infrastructure change. Also, just for industry, there is the scheme of zero liquid discharge that has advanced technologies and high quality demands, while smart water improves processes by data transmission, data acquisition, and so. However, these schemes, in the case of zero liquid discharge, needs to be implemented only in places with high crisis, high hydrological crisis, due to the high cost and also the high technology that is needed to be implemented. In the case of smart water, it only focuses on data, but still is missing the hardware part and the control part. So there's a gap in here.
So the opportunity we saw, it was the lack of a scheme, like they mentioned before, especially dedicated for the industry. And as the system knowledge is what's missing for reaching sustainability and resiliency. So after that, we came up with the idea of artificial clouds. We saw that on many processes, nowadays, the use of water is mostly to clean, dissipate heat, or sometimes to submerge any product in it. After that, the water is disposed and not ever used again. So that's why our goal came with to reduce the effects of water consuming in an industry. So that's when we came with the idea of the artificial cloud. This is a container of water residues, and this water gets condensed and it's able to reuse it. The materials we can use needs to be hygroscopic, recyclable materials such as polylactic acid and PETG, and an adaptable grid that provides a resistant structure that can be used. But the importance here is that there doesn't have to be a really big structural change, so it can be applied in every single industry.
With this adaptable technology, we can develop a smart water crisis-proof industry. What do we mean by saying this? Adaptable, that it can adapt to needs, high impact and low cost. Many developing countries are in need of these schemes. However, they don't have the resources in terms of human resources or even monetary resources. So making this adaptable technology and also a scheme will provide important results. Also, by managing a smart water industry with a system approach, artificial intelligence algorithms, data analytics will prevent errors and will also help correct them. By using optimization tools, it will be better to have a better insights, explorations, and solutions. And also, with the help of digital twins, it will be easier to find solutions without implementing, without changing the whole structure at the first time. And it also will allow us to see the main problem. Sometimes the solution is not only high-tech, but the change of paradigms. Also, this smart water crisis-proof industry is crisis-proof because it can prevent crisis. It doesn't only reach sustainability, but also it prevents chaos from mitigating effects of economic, social, and environmental crises. And also, it is adaptable to industrial and urban applications. It also engages cooperations among sectors and reduces the amount of virtual water. It provides improvement for communities, individuals, companies, and governments. So within the conclusions of these papers is that solutions to real problems require a systemic approach. We cannot see it from a single point of view because water joins every human task. So high tech needs to be accompanied by a scheme. We cannot just come by and say that our high tech can solve every problem, but it needs to be accompanied by real solutions and by a whole perspective of the system. Also, adaptable technology like the artificial cloud is required, so it can be implemented without stopping production and without changing infrastructure. Low tech also can provide important results. We don't always need high tech. We can also adapt to the circumstances of the company. We can also adapt to the countries we are in, and also achieving sustainability in terms of waters tackles the whole system, tackles every activity, and even changes the inequalities. Also, sustainability can prevent crisis. It's not only about reaching sustainability, but preventing crisis in terms of hydrological, economical, environmental terms. So this is all, and thank you very much for your attention.
Thanks a lot.
Are there any questions? Thank you.
Any questions from the audience? So I have a question. If I understood well, you may be referring to potential in water waste into 0%, which is basically perfection. So practically speaking, can you foresee an implementation that is not as perfect, and what kind of percentage you could expect from this real application?
Of course, by instance, we're not looking for 100% maybe, but we are looking for a whole scheme. It's not only about putting zero waste, but also by catching, by implementing like the schemes of 4 taps or even sponge cities, that it is integral. It's not about only waste, but it is about how is water managed from the time that it rains till the time that it is disposed to the environment. Maybe we could not reach like the 100%, but we could reach 99%, which is very important since industry is one of the sectors that uses the most water. It is vital to change the way it is managed, principally in industry, so it can tackle also in the home scale, in the resident scale. It's not on, and also this has a view that it could be implemented in the primary sector due to the high importance of this. It's an integral part, it's an integral scheme that it's not only focused on zero liquid discharge, but it is also intended to have a background, a life cycle thinking, and also a user-centered design, because sometimes we forget about the user, we forget about how that water is being handled at the end use. At the end use, I mean, in the industry or at the home scale or in every scale, because the actual person, the last person to use it will be returning that water to the environment. So if we can change that, if we can captate more water, if we can catch more water, if we can also change how the whole cycle of water is being managed, then we will tackle the problem.
Thanks for your large and good reply. Very interesting work. So I'm gonna ask to the first speaker if he's available right now, Carlos Alberto.
Yeah, I'm here again. I will try to present a PDF because I don't have the option to share the complete screen. I don't know why, but let's see if we can do it this way.
Sorry, Pietro. Just an update. We are sure that the fourth speaker is missing because he sent us an email. Then we can be also more relaxed with the session.
Okay.
Okay, thank you. So let me try if we can move the slides. So you now you see the first one, right?
Vittorio, you mean Ivan Ferretti?
Yes, Ivan Ferretti. Yes, he's missing, definitely.
Okay, Carlos, the floor is yours.
Okay. You can see the first slide, right?
Yeah.
And you can move it now. I am in the second.
Okay, yeah.
But you just see the first one.
Right now is the second one, but let's see.
And the third?
Yes.
Okay, it's moving.
Yeah.
Great.
Yeah, it's slow, but I think you can change the slide slowly, and there is no problem. Just,
okay, I will be slower between the changes. So
as Vittorio said, we have time, so no problem. Go ahead.
Okay.
Don't worry.
Thank you. Well, as I say, I will present the paper with the topic waste reduction in printing process by implementing a big inspection system as a human-machine interface. First of all, I want to talk about the problematic that exists in the graphic industry because the most recent advance in advertising and marketing have derived a need for higher quality printing jobs in regards to design and finish. Here it's important to say that in consequence, there is a decrease in the volume of printing jobs in terms of linear meters per job, but also an increase in the diversity of jobs. Let me explain this with an example. Think in milk products. Years ago, we only had the regular milk, and we can choose between two options, the half-liter presentation and 1 liter presentation. But nowadays, we can choose between many variety of options, like the regular milk, the lactose-free, the fat-free, with protein for 40 years and more, and also between many different flavors. Add to this, also we can choose with a lot of options of size. All this has led to an increase in waste due to production errors and customer rejects. And as a solution to reduce this waste, the graphic industry is now requiring updates to equipment to improve its process. One of the most important problems is due to the printing speed. Quality errors by defects on the printed roll or in the surface of the material are unpredictable to the human eye. That is why the video inspection system takes relevance because helps the operator to do his job with better quality in less time. So here are two big questions. The first one is, what is the profitability of the system? And the second, is the investment justified? For answer these questions, one company in Mexico City let us make the research. Unfortunately, due to the current situation with COVID-19, it was not possible to carry out the necessary measurements to validate the system. Therefore, only the proposed methodology will be described. For the methodology, we will follow 7 steps to develop. The first one is about the video inspection system, price and selection. The second is the data collection before installing the system. The third is the video inspection system installation. The number 4 is the data collection after installing the system. The number 5 is about the waste value identification and estimation. The number 6 is the data comparison between the price of the system and the value of the waste for obtain the break-even point, for finally, in the number 7, to the video inspection system validation. For the point number 1 of the methodology that refers to the price and selection of the video inspection system, we did an evaluation of 4 of the 4 main brands of inspection system that actually are in the market. The first one is a Canadian brand that offers a high-resolution camera with motorized travel reel. That means that the camera travels through a reel for inspect all the web width of the material, and the price is under the average of the market. The second one is a German brand that also offers a high-resolution camera with motorized travel reel, but the price is in the average of the market. The third one is a US brand that offers a HD resolution with many cameras for 100 inspect of the printing area, and the price is of the average of the market, and it depends on the number of cameras that the machine needs, 1 camera for each 10 inches of web width. The fourth one is a Japanese brand that also offers an HD resolution with many cameras for 100 inspection of the printing area, and also the price is of the average of the market. Then we need to evaluate the waste in terms of money. This includes the steps number 2, data collection before installing the system, number 3, video inspection system installation, number 4, data collection after installing the system, and number 5, waste value identification and estimation. And for doing this, first of all, we need to quantify the total waste by production and rejected jobs. The quantified table is an example of how we will do these measures before and after install the system, or finally obtain the average in linear meters of the waste with the inspection system and without the inspection system. And the difference between these two averages will be the saving waste that the system produces. Once we have this difference, we need to evaluate it. In the value table, you can see 4 of the principal factors that increase or decrease the value of the printing job. The first one is the material cost, the second one is the ink cost, the third one is the finishing cost, and finally the fixed cost. And with all this value, we can estimate the saving cost that the system gives. With this average of the saving cost per month, we can follow to the final 2 steps of our methodology. The number 6, data comparison and analysis for obtaining the break-even point between the price and the saving cost, and finally, the video inspection system validation. As I say, for validate the investment, we need to find the break-even point in months where the price of the system is equal to the saving cost. In the image, we can see an example of how we will find this recovery time. And for example, if the company selects an expensive system, the break-even point will be moved forward. Or if the company print on many expensive material, the point will be moved backward. That means that the recovery time of their investment will be faster. Finally, the conclusions. First, the importance of this research is because the video inspection system brands currently don't have a quantitative analysis of the real cost reductions of having the system. Also, it's important to highlight that the return of the investment is directly related to the value of the waste. And finally, this type of equipment helps human-machine interaction by making the operators less susceptible to errors which allows them to be more efficient and in consequence be able to do higher quality jobs in less time. Thanks for your attention, and if you have any questions, feel free to ask.
Thank you, Carlos. Any question from the audience? I have just a curiosity. Do you think there will be any privacy issues in implementing this kind of system in manufacturing factories with workers, operators? Yeah, because with the technology nowadays, there are this kind of systems connected by Ethernet, and so they need to take care about the privacy, because the brands of that fabric these equipments have access to that information. So I think there is an issue about the privacy in terms of these equipments. Okay, yeah, as expected. Yeah, now it's only the web. Right, if there are other questions, feel free to ask. Otherwise, we can skip to the third. We can skip the fourth and go to the third, sorry, because we have the third speaker, is Chiara. The next paper is titled A Model for the Economic Assessment of Disassembly Line Integration. Okay, so we have integrated production, distribution, scheduling with energy considerations for efficient food supply chains.
Yes, Vittorio. Thank you, Pietro, for your introduction. Can you see my screen?
Yes.
Okay, thank you. Good afternoon to everyone. I'm Vittorio Solina, PhD student from the University of Calabria, and today I'm going to talk about a paper entitled Integrated Production Distribution Scheduling with Energy Considerations for Efficient Food Supply Chains. This is a joint work. I wrote this paper with my professor, Professor Giovanni Mirabelli. First of all, a first slide about the background and the motivation behind this work, this research work. The starting point was some considerations about the current situation on food waste and sustainability. First of all, according to the Food and Agriculture Organization, food production should increase by 70% in the next few years due to the expected growth of the world population. But despite this expected trend, this expected growth of the food production, nowadays, according to some authors in the literature, up to a third of the food produced in the world is still wasted due to inefficiencies in the supply chains. Just think, as written in the slide, unharvested crops or expired unsold food products and so on. And also about environmental sustainability, there are some important issues nowadays, because a large amount of water and energy is wasted, a great quantity of greenhouse gases is still generated, and so on. And there are some problems despite the efforts of the last years. And what about the situation in the supply chain and in the food supply chain? When we talk about supply chain management, we can say that in the past years, after an analysis of the literature review of the literature, we can say that the trend in the past, the tendency in the past was to locally optimize each single stage of the supply chain, then only production, only distribution, then to join inefficiently, we can say, the solutions obtained from a production plan and a distribution plan joined together. But recently, we can say we read some literature reviews about this topic, and we can say that there is a new trend. New quantitative approaches are proposed to integrate, to create an integrated plan about production activities and distribution activities. And the main reasons behind this trend, we can say, are the frequent market changes today, additional customer needs, because today the final product and also food products are very customized, even more than in the past. And in general, quantitative approaches like these are useful to face the uncertainty typical of the supply chain. And then our main aims are summed up in this slide. We would like to propose an optimization model to determine in an integrated manner the production and the shipping or delivery or distribution plan for a real-life food company. We propose first an optimization model to do this, and then we test and validate it through 10 instances generated from the historical data of a real-life food company which produces vegetables. And in this context, we compare two rescheduling strategies. The first one is the partial rescheduling, that is the strategy currently used by the company, and a new strategy named complete rescheduling. And we have decided to implement these two rescheduling strategies into a rolling horizon framework, and I'm going to explain each point of this slide. What about the model? In this slide, the model is quite complex, but in this slide I tried to show the main sets and the main parameters of the model. We have a well-defined, specific time horizon, then a set of weeks divided into a set of days, and each day is divided into a set of working slots. Each working slot lasts 1 hour, and we have a set of products to be manufactured, and a subset of these products have highly perishable raw materials, are characterized by highly perishable raw materials. And then we have a set of customers to be served through a set of vehicles. Then about the production area, what about the parameters, the data? We know the amount of, it's important to say also that we have a single production line. And about the data, we know that the amount of energy consumption per slot during the day, in case each product is manufactured. We know the energy price and the demand of each product by each customer. About the inventory, we know the shelf life of the raw materials, highly perishable raw materials. We know the storage cost. We know the storage capacity of the inventory. About the distribution step, the distribution phase, we know the capacity of the vehicles, that in general is different according to the vehicle. We know the shipping cost. We know that there is a fixed number of weekly shipments expected, imposed by the customers. What about the decision variables of this model? We have to decide for each working slot of the day. We have to decide how to set up the production line for product 1 or for product 2. In general, the product are different and require a different setup. We have to decide how many units for each product to manufacture, then to produce per each slot. We have to decide the inventory level at the beginning and at the end of each day, and the amount of product shipped by each vehicle to each customer each day. What about the main constraints? Then the main assumptions behind the model. The production line must be set up for exactly one product at a time, at each time. There is a production capacity for the line. There are some changeover times in the sense that when if I decide to produce the same product for each slot of the day, I have no changeover times. If I decide to produce on the first slot product 1 and on the second slot product 2, I have to consider some changeover times for hygiene reasons, for the sterilization of the line, and we have to say also that each product has its own parameters. Just think to a pasteurizer which has to process different products at different temperature and so on. Some constraints about raw materials perishability. We have to respect the customer demand, not only about the products to be shipped to each customer, but also in terms of time. Each vehicle has a capacity. Each vehicle, for reasons related to the distance, can serve not more than one customer per day. There is a fixed number of weekly shipments for each customer, and the deliveries, the shipments are allowed only on some days of the week. For instance, on Sunday, there are no deliveries. This is the proposed optimization model. We have, I can only say, I can explain, I have just explained the different constraints, but we have no time to explore each single part of this model, but we can say that it is a linear model. The objective function is to jointly minimize energy inventory and distribution costs. We have considered, as I said, a real-life case study, in particular an Italian company in the south of Italy, near our university, dealing with production, distribution, and inventory of vegetables, in particular vegetables preserved in oil and in jams. And we have 6 different product families. We have 2 daily shifts of 8 hours each, and 2 vehicles for the shipments and 2 different customers. Then we can say that the size of the model is, I think, small, medium, but for sure not so large for the case study. We have generated, starting from the historical data of the company, we have generated 10 different instances, 10 different cases, and we have considered for these 2 parameters, then energy price and demand. We have generated them by using a normal distribution with the 5% of coefficient of variation. Instead, all the other parameters were known. For instance, the capacity of the vehicles, or the storage capacity, the production capacity of the single line, and so on. In particular, we have generated the energy price starting from the historical data that are free open access from the website of Gestore dei Mercati Energetici, which is in Italy the company responsible for the management of the electricity prices, while the demand was generated starting from the historical data we have from the company. We have implemented then this rolling horizon scheme. How to explain this rolling horizon scheme? First of all, we have implemented the model into using a software named IBM iLog Cplex. We have the academic license for it. The rolling horizon scheme works in this way, very quickly. If we have a time horizon of n weeks, we have n-1 iteration. On the first iteration, I receive the customer orders at the beginning of the first week, and I plan the production and the shipping. Then these two symbols are production and shipping plans for the next 2 weeks, because I suppose to know, because I suppose that on the first week I can look only to the next 2 weeks. Then, if I consider a complete rescheduling strategy, on the second iteration, the horizon is rolling. Then we look to the second and third week. Then, according to a complete rescheduling approach, these two plans, production and delivery, are deleted and are rescheduled, redecided. While if we refer to a partial rescheduling approach, that is the approach used by the company, the decisions about the production plan are taken on the first iteration, are fixed in the second one, and so on until the last iteration, when we have decided all the plans from the week 1 to the weekend. In this slide, we can see the difference between partial and complete rescheduling, as I have explained in the previous one. Basically, on the first iteration, I decide a production plan and a shipment plan. If I decide for the partial rescheduling, the production decision taken on the first iteration are fixed, and for next iteration, instead, I have an empty schedule if I refer to the complete rescheduling approach. What about the computational result? We can say that the complete rescheduling strategy can improve the current practices of the firm, because we can obtain overall savings greater than 4%. In particular, about the energy cost, we have a decrease of about 10%, because mid-peak and off-peak hours are better exploited, and we have some improvements also about inventory and delivery management. And the computational time was very limited. I remember few seconds, I think not more than 2 or 3 minutes. Then the model can support the company, obviously at an operational level. Then to sum up, to conclude, we can say that we have designed and tested an optimization model to support a food company with production, inventory, and distribution activities related to vegetable products in a way that we can consider these activities in an integrated way. The model considers several real-life features, such as the hourly fluctuations in energy price, the changeover times on the production line, and the shelf life of raw materials. The computational tests show that the proposed complete rescheduling approach is better than the partial rescheduling typical of the company. In the future, we would like to test the model on larger instances to multi-line. We want to consider a version with more than one production line, and the idea is to include this framework into an advanced automated planning system in accordance with the Industry 4.0 paradigm. I thank all of you for the attention. Here in this slide, my email and so on. Thank you.
Thanks, Vittorio, for your nice presentation. We have questions from the audience. I'm going to ask you the same question as before. Are you going to share this code with this model, with the industry or the academia in the future?
Yes, why not? It could be applied, as I said, at an operational level. There are many food companies that could be interested in using this model. Then why not? Yes.
Great. Thanks again.
Thank you.
And I think we have finished our presentations today, and I'd like to thank all the attendees on behalf of the chair, Professor Giovanni Berselli. And I'll give my most sincere regards to all of you, and we look forward to see all of you in the next year for the next conference. So if there are not other questions for the authors, I think the session is closed.